Hello and welcome to another quick maths tutorial. Today will be the final rule of derivatives that I'll be showing you, called the quotient rule, in our topic on differentiation. And in the next video we'll be looking at a bit more applicative use of derivatives, such as on trigonometric functions, which the quotient rule will be important for using. So as you know, there's four main rules to derivatives, and this is the final one. Quotient rule. And the last one we looked at the product rule, which I showed you how to figure out the derivative of the product of two functions. Whereas in this video, we're looking at how to find the derivative of the ratio of two functions. Since division, which is going on here, is a non-commutative operation, which means it matters which way around the two terms involved are. So the two functions f and g of x I've labelled, doesn't matter what they are, but it matters which one's the numerator and which one's the denominator. So if I show you the method of finding this here, you see that dy dx, when y is equal to the ratio of f of x to g of x, the derivative of y is equal to the derivative of f of x multiplied by g of x minus derivative of g of x multiplied by f of x. And this is all divided by the function g of x, so the denominator, squared. So it's important, as remember it's non-commutative, which way around f of x and g of x are. As you can see, the numerator of this looks a lot like the product rule, with a minus sign instead of a plus, but otherwise these are the same, and it matters what's on the left hand side and the right hand side of the minus. Remember, the function on the bottom is squared. So this is going to be a short video, so I only have one example prepared for you, because I will give you a lot more examples in the next video of where this is mainly used. But for say, we see that y is equal to x minus 1 over 2 of x. So it cannot be simplified any further, so we cannot change it into a better form to use a different rule, so we're going to have to use the quotient rule. So if I write that dy dx, zoom out a bit, is equal to, now let's input f of x and g of x into this to find its derivative. So we want the derivative of f of x, which is x minus 1, that's just x, using our power rule, times by g of x, which is 2 of x, minus, so we'll calculate their product first, and derivative of g of x, which is 2 of x, that is 2, times f of x, which is x minus 1, I'll expand that later, all over g of x squared, 2 of x squared, and I'm going to simplify this further. Okay, so x times 2x is 2x squared, minus, expand this bracket, the 2 times is the x, we get 2x, it's minus 2, so we'll get minus 2x, the minus 2 times the minus 1 gives us a positive 2 plus 2, and we're still all over 4x squared. If you want to leave that in its final form, we'll take out a factor of 2 from both sides and get left with x squared minus x plus 1 all over 2x squared is our final answer. So that is the formula for any input of x to find the derivative at that point of x of the equation of the line x minus 1 over 2x. So I hope you enjoyed this video. I hope you got a better understanding of derivatives, and this is the final rule, so thanks for watching.